What is the area of the inscribed circle? Also, find the value of x. Let A be the radius of the quarter circle. Label point K and Y. The length of an arc of a quarter circle. L equals half of pi times R, which equals to 4 times pi. Cross multiply and solve for R. It follows that R equals 8 centimeters after simplification. Hence, line OB equals to line OA, which equals to 8 centimeters. Also, let the center of the inscribed smaller circle be G and its radius be small r. Join line OY, line GD, and line GK. It implies that line GY equals to small r and line OY equals to r. GKOD is a square with a diagonal. Line GO equals r minus small r, which equals to 8 minus small r, and each of these listed lines equals small r, that is, the radius of the inscribed circle. From triangle GOD. Using Pythagoras' theorem, the square of line GO equals the sum of the square of line DO and the square of line GD. Substitute values and we have that the square of 8 minus small r equal 2 times the square of small r. Expand bracket. It signify that 64 minus 16 times small r plus the square of small r equals 2 times the square of small r. Rearrange terms in one side of the equation. We obtained an equation in small r as shown on the screen. Use general quadratic equation formula. That is, small r equals negative b plus or minus the square root of b squared minus 4 times the product of a and c, all divided by 2 times a. Where a equals 1, b equals 16 and c equals negative 64. Substitute values into the formula. We have that small r equals the value shown on the screen. Simplify and we have that small r equals negative 8 plus or minus 8 times the square root of 2. Hence, small r is not equals to negative 8 minus 8 times the square root of 2. It is because length measuration has no negative value. It implies that small r equals the sum of negative 8 and 8 times the square root of 2, which equals to the product of 8 and the square root of 2 minus 1 in centimeters. Therefore, area of the circle equals pi times the square of small r, which equals to 64 times the product of pi and 3 minus 2 times the square root of 2 in square centimeters. Solution to question 2. Join line D, K, which is equals to line GO. They are the diagonals of the square GKOD. It follows that line GO equals to line D, K equals to 8 minus small r. Substitute values. Line D, K equals 8 minus small r, which equals to 16 minus 8 times the square root of 2. After substitution and simplification of value. Therefore, line D, K equals to the product of 8 and 2 minus the square root of 2. In centimeters. Also, join line E, K, and label point T. Since labeled angle G equals 90 degrees, it signifies that angle DEK equals to half angle G, which equals to half of 90 degrees. The result equals 45 degrees. It is because angle at center is twice that at the circumference of the circle. Again, triangle DET equals to triangle K or ET. Conditions are given in bracket. This implies that line EO is an angular bisector of angle DEK. X equals half angle DEK, which equals to half of 45 degrees. The result is equals to 22.5 degrees. Hence, tan X equals to tan half of 45 degrees, which equals to square root of 2 minus 1. Therefore, tan X equals to square root of 2 minus 1, which equals to 0.4142 to 4 decimal places.